Hello everyone, and welcome back. So, this time we'll be talking about covalent bonding. Okay, covalent bonding. Now, what is covalent bonding? Well, you might have been wondering last time, well, what happens if we have similar electronegativities? Neither one of these atoms wants to take electrons more than the other. Well, like good friends, they learn how to share the electrons, so they both effectively have filled shells. So hydrogen wants a filled shell, this hydrogen wants a filled shell, and so together they have 2 electrons, which means a filled shell. So this happens when we have similar electronegativities. Now you might be wondering, okay, well what about if it's like 2.1 and 2.2? Well, then it's mostly covalent, but it'll have something called ionic character. The more the difference, the more ionic character it has. The less the difference, the more covalent it is. Now, there's also something very interesting that happens when we have these kinds of bonds going on. For example, carbon can form hybrid orbitals. Now, like, okay, what's going on here? Well, this is what it looks like, right? This might be where we start. We have 2 filled s orbitals. We have 1 empty p orbital. But what carbon will do is, rather than having this filled s orbital and this 1 empty p orbital, it starts looking for some sort of balance. It wants to balance them. And what it does instead is it mixes these together. So instead of having 1 s orbital and 3 p orbitals, it makes 4 sp3 orbitals. So none of these orbitals is bigger than the other. They're all the same shape. And this is an amazing thing to learn. It's not always that easy to show, but I'm going to try to show it to you. Well, an s orbital, it looks like a big circle. And this is how the probability distribution looks. You can't really see it's just a big circle. A p orbital looks more like this, right here. And so what's happening then is we're adding these together to make those sp3 orbitals. What happens is this is more or less, let's just say it's a positive orbital and this is a positive and this is negative right here. It's not really positive and negative, it's just as close as I can get to with a little example. So the positives add and the negatives subtract. What we get when we add those 2 together is something that looks like the following. We have a bigger positive side and a smaller negative side. Big positive, smaller negative, because we mixed it together. But if you remember, there were 3 p orbitals. So there's 3 different ways they can mix it all together. And then also we have our original s orbitals. So that's where we get these 4 orbitals from, because we're trying to make sure that it's all equal. It really wants that equalization. So bond hybridization is something that happens in the real world, and we can tell that it happens when we have intriguing shapes that don't match what we might guess, because these orbitals are how things bond together. They're trying to overlap the probability distribution. So if I had a p orbital, and I'm trying to bond to another p orbital, well, guess what? They're going to bond at something like this. They're going to attach, most likely, right there. Or they might attach on the sides right here. So they're attached here and attached here. That's how they're going to attach. So when carbon, it does something like this, where like there's something really weird going on here. This doesn't look right. And so that's where bond hybridization came from. We realized we had to mix the orbitals together. We couldn't just look at them as separate creations. No, those other orbitals are going to be affecting our outside orbitals. Okay. Now, if we look at carbon, we see this in real life in things like CH4, which I believe is methane. You can check that on me if I'm wrong. Send me an email. I'll give you extra credit point. I'm thinking it's methane. And so we see that carbon, for one, has 4 bonds. It makes sense that all 4 of those bonds would be equal in strength. And so the only way we can get that is by having these hybridized orbitals. And so when carbon bonds with something like hydrogen, well, then hydrogen overlaps its probability distribution with each of these orbitals right there at the tip. Now, are these orbitals sharing electrons, or are they stealing electrons? Well, carbon and hydrogen, they have similar electronegativities, And so the electrons are shared. So these are covalent bonds. That's even though hydrogen is sort of a metal and carbon is a nonmetal. Well, that's everything for today. Next time we'll be looking at 2 more different types of bonds, and then we'll be wrapping up. So I hope you've enjoyed this. I'll see you all next time. Bye-bye.